Welcome to module 22 of database management systems. We have been discussing application design and development. This is the second part of that discussion. In the last module, we have taken a quick look at the application programs and user interfaces, looked at the fundamental notions of web and specifically the servlets and JSP. In the current module, we would like to understand the three-tier architecture in little bit more detail and quickly take a look into the rapid application development processes, what kind of help is available for quickly develop applications, and then we briefly will look into the issues in terms of an application's performance and its required security. And at the end, we will discuss how a mobile app is similar to such web based database applications and how they are different. So, this is the outline, the 5 parts. So, in terms of the application architecture, again the presentation layer or the user interface, business logic layer and the data access layer, the front end, the middle tier and the back end. Now, in the presentation layer or the user interface, it is typical that applications follow what is now known as MVC architecture, model view controller architecture, where the model is kind of the business logic that that is implemented in terms of the front end information. View is the actual presentation of the data, that HTML, and controller is one who receives different events, execute actions and so on, and then we will go into the other layers. So, here let us try to understand this flow. So, there is a request in the web browser, say to the service. So, this is the sequential. Now, let us say we are trying to log in to Gmail. So, in one we send a form, HTML form, which has the username and the password and possibly encrypted, that comes to the controller. So, which basically controls the different events. So, the controller knows that it has to now decide whether this what actions are required in terms of this input data. So, it sends it to the model, which is the business logic here. So, the business logic model knows now well. So, at this there is an application which deciphers the business logic, which says that the business logic required here is you have a password and you have a username. So, now you have to decide whether this user is a valid user and whether he or she can be allowed to log in. So, the model has to check on the user data, the user ID and password data, and therefore, it has to come from a database. So, it passes on this request to the data access layer. The data access layer in turn accesses the database. So, you can think of data access layer is something like a SQL query layer, where you have formed a query, select etcetera from etcetera, where user ID is equal to PPD, password is equal to XXX. The database depending on what is found in the database is back to the model, and the model then sends it to the controller. It says, okay, this is what I have found. So, this is the result of the data that result of the request that has been prepared. So, it says that well, this is been found and therefore, we have extracted the mails in the inbox that existed, or it says that the authentication is not possible. So, it plugs in a error message and sends it to the controller. Controller now knows that a response has to be framed. So, the controller sends it to the view of the MVC. The view will prepare the HTML that needs to go back. So, view prepares the HTML and sends it back to the controller. So, controller now has a response which it sends back to the web browser through the internet, and we get to see that well, now my inbox and mails are all here. So, this is a complete flow of starting from here, going through this, coming back, going here, going back here is a whole route of the request response that goes over the HTTP in a typical web or application scenario. That is the way this application architecture is expected to work. So, here I have created a small table showing you the different activities that happens at the presentation logic and data layer of different common applications like webmail, like Google. So, at the presentation layer you will do things like login, mail list, view, inbox, sent item, outbox, so on, mail composer, so that you can write mails, filters of checking at different mails. So, all this happens. So, for example, if you talk about filters, they might often happen in the JavaScript itself that runs within the browser. The logic, the business logic will do user authentication, connection to mail server, because our mails have to come from a different server. They are not, they may not be sitting tight in terms of the database itself, and then usual encryption, decryption, and the data side you will have different tables to represent the mail users, the users like you and me, all who are users of the Gmail, the address book of for each one of us, the mail items and so on, and that will give us the functionality of send, receive mails, managing address book and so on. So, similarly, I have listed an application for net banking, which where you can check balance and do transactions, transfer funds, or a timetable where you can manage timetable for multiple courses taken by multiple teachers and so on. So, you can, if you think about an application, then you should be able to moderately map its functionality across the presentation logic and data layers, so that you know what you want to do at the client's end, which is at the presentation layer, or what you want at the absolute back end, which is on the data, what tables and all the databases that you want to maintain, and the business logic of how actually this application will give you the results, how actually it will. So, that is something where you will have a whole lot of complex logic that might come in. So, coming to the business logic layer specifically, that provides abstraction of, that will provide abstraction of various entities, students, instructors, courses, mails, your accounts, balance and so on, and that will enforce business rules for carrying out this. So, a student can enroll in a class only if she has completed prerequisites. You can transfer funds from one account to the other, provided you have the authority to transfer, provided you have enough funds in the account that is going to get debited and so on. So, those are the different business rules which will be employed by the business logic layer, and it will support a workflow which defines how a task will be carried out in terms of the multiple participants. And remember that all participants may not actually be human beings, they could be, some could be human beings, some could be other machines or other applications as well. So, it gives you the workflow. So, you can any of the three applications that I just mentioned, everywhere you can find that there is a workflow. If you want to check a mail, then there is a steps that you need to do, go to the inbox, choose the particular mail item, get the body, and then if you want to reply to that, select that, submit that, you get a new form where you write the reply, and within that form you get the original copy of the original mail and so on. So, all these kind of workflows will be supported by the business logic layer. Now, certainly you can understand that at the front end, if we talk about what are our different languages and models that we are working with, in the front end naturally our language is HTML, nice for presentation, embedded with JavaScript. At the back end in the data, it is the database and the SQL query. So, it is a relational model, but what happens in between, what happens in the business layer which connects them. Now, naturally in business layer you could write complex business rules, for example, in the timetable application we will have a complex algorithm to find out what allocation of classrooms and slots are feasible for assignments of teachers to courses, availability of rooms and so on. So, often the business logic layer, this tier would be convenient to write in some typical common high level language like C++ or Java, and naturally you would know from your experience of software engineering that if you have a object based language, then that will be very convenient to do that. So, which means that if you have say some entity as a student in your relational database, then most likely in your business logic, which is a Java code, you will have a class called student. So, the relation student is in the relational model and your class student is in the object based model, and you will need to define these in terms of certain mapping of the attributes, which we had shown when we talked about embedding of languages. And this is what is commonly known as the object relational mapping. So, that objects can map to multiple tuples in multiple relations and can be viewed in a different way. So, through this mapping itself, we could create a virtual view in the business logic layer, in the business logic language that you are looking at. Of course, there have been attempts to create models which are relational models which are also object oriented. Those are called object relational databases. Some of them have been successful, but not really commercially successful. So, we continue to work with SQL and relational database kind of things in the database level, and some kind of a high level language like C++, Java and a object based model in the middle tier in the business logic, and continue to do the object relational mapping for solving the problems. So, you can here I have given the points of what happens, how the objects get created. Application opens the session which connects to the database, because you need to get the data from the database. They can be objects can be created, saved to the database, they can be extracted from the database, new objects can be created, and mapping used to create appropriate tuples in the database. So, it is a two-way traffic that will keep on happening, where the business logic layer will continue to see entities as objects, whereas the database layer will continue to see them as tuple in the relational database. So, there are also several web services that can be used, and you may be getting familiar with that. We will not go deep into this, but I will just mention that web service is a mechanism through which you can access data from remote server using what is known as a remote procedure call. And today very common approach for this is called REST, representation state transfer, which allows standard HTTP request to a URL to execute a request and return data, and several of the web services are based on that. Another are big web services which you must have heard of, but I just mentioned it at this point because it is contextual, but we will not get into those in this course really. Now, coming to how do you actually develop applications. Now, it is not an easy process, there is a lot of effort required to develop web applications. You need to support the functionality that of current day web. So, you need several approaches to speed up applications. So, this is in parallel to, if you think of what has been done to speed up development processes, development applications for different say C applications or C++ or Java applications. So, one approach naturally is to have variety of function library which can help you easily get user interface elements like buttons, checkboxes, radio, drag and drop features in the IDE. IDE stands for integrated development environment, like Visual Studio, front page, this kind of, which can which can create user interface elements easily. You can automatically generate code for user interface, and these are all parts of rapid application development tools. And some frameworks are very popular. This is primarily the Java Server Faces or JSF is a framework where you can rapidly develop, fill in all the requirements of the different layers in a web based database application. Another very popular is Ruby on Rails, which allows easy creation of simple crude create, read, update, delete. So, if you look at database applications, and common applications will, all applications will at least need to do this. It will need to create data, read data, update data, delete data. So, you can do that quickly using Ruby on Rails. So, if you are getting into really the development of database applications, get yourself familiar with this rapid application development processes. There are different other frameworks as well. Another very popular and widely used framework is Microsoft specific. This is unfortunately not portable because it is proprietary of Microsoft, where you can use the .NET framework of Microsoft, which helps you with lot of resources and libraries which are already provided, and like we talked about JSP, you can use ASP.NET here, active server page in the .NET framework, which provides a whole lot of controls, and you have a very nice powerful IDE in terms of Visual Studio. However, being proprietary, these need licenses and you need to pay for that. So, many a times many developers may not be able to afford it or like it for that reason. Naturally, as you design applications and create that, you will have to be careful about its performance, because certainly we all want very fast results. So, if I log into my Gmail application, and I would expect that as soon as I press the submit button, within couple of seconds my inbox will be displayed on my browser. I am not ready to wait for 2 minutes, 3 minutes, 5 minutes for doing that. So, while developing the application, you will have to make an estimate of how often it will be used, how many users will use that every day, and so on. What is your expected hit rate, that is, when the maximum number of users are trying to use this, then what is the estimated number of requests per second that will come to your server. And to improve performance, there are different kinds of techniques can be used. The significant of them is called caching. Caching is nothing but if you expect two requests to be similar, so that their results would be similar, then after the first request, besides sending the response back, you actually keep a local copy of that, so that if a similar request come in future, you may not recompute it, you can just send that cached copy. So, it can be done in terms of variety of JDBC connections called connection polling. It can be done in terms of database queries, caching of generated HTML, and so on. It can be done at the client's network side also by caching pages by web proxy. Obviously, if you are using caching to improve performance, you will have to understand lot more of the web dynamics in depth, because certainly if you cache, then there is a possibility that somebody is asking is sending a request for which the response would not be the same as what it was when the last time the response was computed and cached. So, if you send the cached information back, then you may be giving a dated information. So, possibly say for example, if you are checking at the net banking transaction, you are making a fund transfer and checking your account transactions after that fund transfer, you would not expect a cached page. Whereas, if you are looking at the website of say IIT Kharagpur, then it will be okay to cache that, because it is not expected to change very frequently. So, these are different factors. So, we do not have it in the scope to go into different issues of how to improve performance and what are the different challenges, but I just wanted you to be sensitive about these issues. Other very deep concern, deep requirement about applications are the security of applications. This is a very involved topic, and there are several issues that are involved. So, and I am talking about only a few of them, because many of them require knowledge about several other fields, particularly in the field of security and encryption and so on. So, one that is very common in terms of SQL query is known as SQL injection, where based on there is, if you are expecting some inputs to come and fill up certain parts of the SQL query, then you will have to be careful that users should not be able to give such input, say such strings, so that the query actually means something different. This query maybe which was just a query to read something, may update something or give some different result. So, here I have just briefly highlighted some of those issues. There are other security issues like leakage of password. If there are important things which are based on a single password, then if the password gets compromised because it is shared or it is broken in the middle by some hacker and so on, then you will have a lot of risks involved. So, you will need to make sure that you do not store passwords, you just store encrypted forms of that, and you check encrypted forms. You must have observed for the last couple of years that In many cases earlier you could just log in, so giving just one password was enough, but now in many transactions, for example, if you are logging into a net banking application, then often you will be asked to provide some additional key information, or you will be asked to do a authentication by OTP, one time password, and so on. So, these are common because it is risky to work with just a single authentication, and you will find that some net banking applications, for example, if you are doing a fund transfer, then they actually require two additional password authentication. One is a special password for fund transfer, and then possibly you will be asked to go through an OTP. So, depending on the criticality of your application and the potential vulnerability of the application, your authentication mechanisms will have to be appropriately designed. There are issues in terms of security in terms of the application level also. For example, if you are looking at a student application where you want to say that the student, every student can see his or her own grade, but they should not be able to see the grade of others. Now, how do you implement this? Now, two issues are, one is the database cannot implement this, database cannot provide this as a part of access control, because database has no idea about who the application users are. And the second, if you recall the way we talked about authorization in SQL, that is in terms of tables or columns of the tables, but SQL has no mechanism to create authorization for rows of the table. So, this will have to be handled in terms of what is known as at the application layer. So, this is where you are. So, what this is saying, that you have created a view where you are created a view student text, where to do this you will have to read, you are saying where text.id is equal to this function called syscontext.userid. So, syscontext is an object naturally, dot user id, this function call. So, what this function gives you, call to this function gives you is an information about the end user identity, and that identity has to match the identity that exists in the text id for the result to be computed. So, this will ensure that depending on who is actually the current user, the same view will be evaluated for different results. So, this is not a very sound, this is not a very comfortable situation, because here the authorization is not being implemented in the database level, but is being implemented at the application level, but that is the way things are, because most of the fine grained authorization currently is done entirely in the application level only. Extension to SQL authorization for similar fine graining and so on has been proposed, but they have not been implemented, because there are several issues of implementing that. There are several issues of how do you represent, how do you model, and most importantly these have potentials of slowing down the database query processing significantly. So, often this is not a preferred mechanism either. Another way to ensure security is to keep audit trail. So, applications keeping audit trail must log actions into it, and so where you write down actions in terms of who carried out an update, or who accessed some sensitive data, or who did a delete and so on. So, audit trails can be used later on if the need arises to detect if some security breach had happened, or if some damage has been caused by the security breach, that can be corrected and so on, create a trace. So, auditing is necessarily a very required activity for any database application, and audit trail are a good mechanism for that. So, when you develop applications, you have to consider as to whether you would like to support audit trail. Of course, if you support audit trail, then somewhat your application will get slowed down, it will require more disk to keep the trail, because every transaction, every details will get logged into the audit trail, but it is very important for critical applications like net banking, where currently it is mandated that every transaction that you do, every action that you do on your account through the net banking is trailed in the bank's end, so that if later there is a there is some dispute, there is some breaches found, then the same can be recovered and traced back to the actions that were actually taken. At the end of this module, let me take a quick look into the mobile apps. These are somewhat different, but it is very important to today to take a notion of the mobile app. So, it is a type of application software which is designed to run on a mobile device. So, it does not necessarily mean that it has to be a smartphone, it could be a tablet or some small device which typically is handheld and can be carried around. So, it is typically specifically for use on small wireless computing devices, and it is designed with considerations for demands and constraints of the device. So, how is it different if I want to use the application or want to have an application which does my task, but I want to do it as a mobile app, I want to do it for a small wireless handheld device. Certainly, there are if we since it is a small device, it has lot of constraints, there are a lot of demands of the device compared to if we were using a web browser in a desktop or a laptop where we have lot of resources. And also on the this is on the kind of the restriction side, and on the other side these devices have certain capabilities which your desktop or laptop may not have, and therefore, it may be you may be able to do more interesting applications using this mobile devices, and there could be really interesting mobile apps. And as you all must be using today, use tens of if not hundreds of mobile apps for different applications, many of which actually support a database at the back end. So, these are in red are some of the negatives which are restrictive in terms of a mobile application. The first thing is form factor, which is the look, the aspect ratio, the size and the style of the device, which influences display and influences the way you navigate. In a desktop application, you will typically use a mouse or a roller and keyboard to navigate, but that is not possible or that is not easy in terms of a mobile device. So, your navigation may happen in a different way, the presentation itself may happen in a different way. You have a very limited display area. So, you might want to stack multiple responses one after the other, whereas in a web application running on a desktop, you would probably have shown them on different tabs side by side, or would have just shown them side by side on the display. Then mobile devices typically have limited memory, they have limited computing power. Very importantly, most of them run on battery, and therefore, they have very limited power available. So, your applications will need to be power optimized, which is not the case with the normal web based application. You have a wireless connection, so which may be limited in bandwidth based on your connectivity at that time, and so on. So, while developing a mobile app corresponding to a possible web application, your considerations would be very different. So, if I say that a bank, say HDFC Bank has a net banking application which runs on the browser, and it is also having a mobile app which runs on say the Android phone, then their requirements and their style of solutions will have to be very, very different. And at the same time, if I talk about a mobile app, then the mobile devices often have features which desktops do not have. For example, you have a number of sensors available like accelerometer and so on, which you can make to advantage. For example, in many smartphones, if we just rotate the screen, rotate the device, then the display itself rotates automatically, which you use some kind of an accelerometer inputs for that. You have a touch screen which can allow a wide range of gesture based navigation, which is typically not possible in desktop and most of the laptops. So, having said that, naturally there are two aspects of mobile apps as well. So, when we are talking about mobile apps, we are talking about the standalone mobile apps. So, there are other ways of developing applications also. For example, we can do a typical web based application but we can use a website which is specifically designed catering to the mobile devices. So, these send back pages which are smaller in size, are stacked differently and so on. So, in contrast to that, a mobile app are actually applications that are downloaded and runs on the system. So, these are all different possibilities, and even though mobile website is also becoming popular, but certainly mobile apps are very common in terms of a majority of critical applications of databases that we have. So, this is a typical architecture of a mobile app. As you can see again here, that you have the 3 layers: presentation, business and data. The only difference being, now since you have a device which can go anywhere, and you have a connectivity. So, this is what shows the connectivity. This is a device side, and this is a pure backend or your service provider side. So, since your connectivity is may not be very strong, you try to create all the layers of presentation, business as well as data on the mobile phone itself, but naturally all the data you will not have on your device. You are checking mails on the Gmail, naturally you will not have all the data on your Gmail. So, what you do is you use the connection to connect to the remote database provided by the service, but primarily most of this layer of this presentation, business and a small part of the data layer are all realized within the phone itself or within the mobile device itself. So, the data layer is split in this case, which is very different from how you do the web based applications, and specifically it might need customizations based on the kind of platform you are using, whether you are using Android, iOS or Windows, and these are all custom solutions for that. And you could also note that there are different types of mobile apps. One large class is known as native application, which is completely written in the native language of the platform. So, for if you are doing an iOS mobile app, then you will write it in Objective C. If you are doing an Android one, you will write it in C or C++ or Java, it is platform specific. Whereas, there is another class of mobile apps which are known as web apps, which run completely inside the web browser. So, much like the way JavaScripts work. So, they feature interfaces built with HTML and the style sheets, and they are powered by different web programming languages like Ruby on Rails, JavaScript, PHP and so on. And certainly, there is a third kind where you combine the attributes of both native and web application, and you try to so you can very easily understand that if your application is a native one, then it is not portable across devices. This is not an iOS application will not run on Android and so on. If it is a web app, then it is portable, because it is portable across different phone, tablet or computer, because you are using generic technologies. So, you could do a hybrid app also, where you could use redundant or common code which is usable across platforms, and add some tailored functionality in terms of the native system. So, these are the typical kinds of mobile apps that you may be developing. And there are several factors to consider in the design issue. You have to first decide on the device, you have to take specific note of the typical resources that you will your device will support: memory, power, speed. You have to consider what should be the bandwidth, should it be 2G, 3G, 4G or wireless LAN, what kind of connections you would expect. Decide on the layers in the architecture, select the technology based on the device choice and the other factors, define the user interface, navigation and maintain the workflow. So, these are variety. I will not go into details of this, but just wanted to give you a glimpse of the fact that in today's time, while you are talking about database applications, then it is a very reality that you will create that as a mobile app. So, in this module, to summarize, we have studied aspects of database application architecture, understood the steps of rapid development, and took a quick look into the issues of application performance and security, and what it takes to what are the distinctive features of a mobile app for database applications.